March 5th, 2021, and it's almost been a year since we have been out of school together and that I've been making videos that long. I'm testing out this new microphone to see how it works making videos. I'll also be using it when you guys are back in the classroom, and you are, some of you will be on the Google Meet as well, those of you who are choosing to stay at home. Okay, let's get going. We are getting into our next inference procedure. This method is a one sample t interval for beta, where beta is our true slope of a regression line. In Chapter 3, we examined data from a study that investigated why some people don't gain weight even when they overeat. Perhaps fidgeting and other non-exercise activity explains why. Researchers deliberately overfed a random sample of 16 healthy young adults for 8 weeks. They measured fat gain in kilograms and change in energy use in calories from activity other than deliberate exercise for each subject. Here are the data. So what we have below, and oftentimes on a free response question, they will give you a mini tab output like this, and they'll give you graphs, so you don't have to do a lot of the graphing. You do more of the interpreting, okay? So the first thing, just to quickly review with you, is one question they might ask on a free response question is find the least squares regression line, okay? So to find that least squares regression line, this black line right here, we need to remember that that least squares regression line is equal to y hat is equal to a plus bx, okay? A is our y-intercept. That is a constant. A is right here. So our y-intercept is 3.5051. And then our NEA change, this is our slope, this is our b. It will always go in that order. I always just try to say alphabetical order, A, B, okay? So again, just a review for you there. Now let's get into some new stuff here. Right here, you do need to know what this value is. Oops. Forgive me, come on. This value right here, this is our standard error of the slope. So I want you to underline that right now if you've printed it off. Okay, standard error for the slope. Next, what you need to know right here, this is new as well. This is our standard deviation of the residuals. Next, a review for you, okay? Right here, this is our R squared. R squared is definitely an interpretation that you need to have memorized. Make sure you pause the video right now and find that in your notes. It's the fraction of variation in y that can be explained by the least squares regression line of y on x. Make sure you know where that is in your notes. I call it a note card problem. It must be memorized. It is often a free response question on the AP Stats test. Now, another question that is, what am I looking for? That I've seen often on released exams is what is your correlation coefficient? Your correlation coefficient. Well, we know that R squared is 60.6%. I'm going to rewrite that as a decimal as 0.606. Well, in order to find R squared, all I want to do is I want to take my calculator and use algebra, and I want to find the square root of that. So I'm going to take the square root of 0.606, and I get 0.77 when I take the square root. So R is equal to 0.7785. Now, we have to be very careful. This is where they are going to tell what type of student you are. Do you pay attention to details? What do we know about the correlation coefficient? As a review, we know correlation coefficient tells us direction and strength of a linear relationship between x and y. Direction means it's either going to be positive or it's going to be negative, okay? Positive or it's going to be negative. Now, one second here. An interruption there, so if it seems disjointed right now, forgive me. What I'm trying to get at right now is our R is either going to be a positive number or it's going to be a negative number. Keep in mind the closer it is to 1 or negative 1, the stronger that relationship is. Now, is our R for this problem going to be a positive number or a negative number? Well, we know that this is going to be a negative number. Why? Because we have a negative relationship here. Okay? We have a negative relationship. Now, what if they didn't show you the graph? Sometimes they only show you the Minitab output. How would I know that this R needs to be negative? Pause and think about it for a second. How would I know that my relationship is negative if I did not see the graph and I did not have the data to plug it into my calculator to look? What if I only had the Minitab output? What could you do? Well, you could look at the slope. The slope is going to tell you the relationship as well, so you would know that this R needs to be negative. Let that sink in for a second. Make sure that you understand that. Again, we're talking about a few review things right now. One last thing to review. If they ask you on the AP test to describe the distribution, remember that we use the acronym SEDS. That is the shape, meaning is it linear or is it curved? That U stands for anything unexpected. The direction is it's a negative relationship. And that strength, how strong is that relationship? Meaning, is there a lot of variation within these points here? Or are they close, really close to the line? How far do they hover from that line? The closer it is to the one, the closer it hovers around that line, the closer that R will be to 1. Okay, one more thing in this part 1 of the video, and then we'll get into the interval. I do want to talk about, we've talked about slope before, we've talked about interpreting the y-intercept, we've talked about interpreting the R squared, we've talked about interpreting the R. Those are all things that you need to have memorized for the AP test. Another thing that you need to be able to do is you need to be able to interpret the standard error for the slope as well as the standard deviation of the residuals. Okay, as well as the standard deviation of the residuals. So to interpret the standard error of the slope, this again needs to be memorized. This is what I call a note card type question. If we repeated the experiment many times, the slope of the sample regression line would vary about, and what are you going to put here? The standard error value. So that standard error of the slope, you're going to put that value there from the true slope of the regression line for predicting y from x. Again, you'll have a chance to practice this in your homework, but in this case, if I was going to actually use it in context for this problem, I would say, okay, my standard error is 0.0007. I'm going to use 4 decimal places. I would say if we repeated the experiment many times, the slope of the sample regression line would vary about 0.000, I think it's 3 zeros, let's double check. It is 7. From the true slope of the true regression line for predicting y, what is our y? Our y is our fat gain. So I would put fat gain here from our NEA. Let's see, what was the unit they used on it? NEA change. So that's how we would do this in context. Again, interpreting that standard error of the slope. Because here's the deal, you guys. This slope right here, this came from a sample. If we did this again with 16 different people, I think that was our sample size, or whatever the sample size is, it doesn't really matter. If we did it again with that same sample size that we had, would we get the same slope? No, we wouldn't, because statistics vary, guys. Statistics vary, and this slope right here, this is a statistic. So if I got that sample, I took a whole new sample, same sample size, and I plotted that relationship again, that slope is going to be different. And what that standard error is saying is it's saying how much is that going to vary from the true slope of the true regression line, that population slope. Let's move on now to the standard deviation of the residuals. Our prediction will be off by an average of about, and you just put the standard deviation value. Okay, so in our case right here, our standard deviation is 0.739853. Our prediction will be off by an average of 0.7399 when using X to predict Y. So when using NEA change to predict fat gain. Okay, ladies and gentlemen, this is part 1 of the video. The next video I'm going to do is I'm going to actually go about and I'm going to calculate that 1 sample t interval for the true slope. And then the next video that I'm going to do, which is our next lesson, I'm going to do a one sample t-test for the true slope. This video was really to go through the Minitab output, talk about some review items, making sure that you understand what interpretations you are responsible for, and some new interpretations as well. Thanks, guys.